Real exam questions. This is question 35, and it goes about slab design. An uncovered cantilevered balcony will be used as a storage place for waste paper. The concrete quality is C2025. The reinforcement percentage of the tensile reinforcement is 0.3%, and only diameter 16 is used. Determine the necessary thickness of the slab. So the support is 500 millimeters width. We do not know the depth of the slab, but the clear span here is 3,500 millimeters. We first look at the slenderness of the balcony. Row 0, the reference reinforcement ratio is equal to the square root of FCK divided by 1000. It's 0.45%. The 0.45% is bigger than the 0.3, or the 0.3% of the slab is smaller than the 0.45, which is the reference reinforcement. So rho is smaller than rho 0, which means that we use this formula. If not, we have to use another formula. So this is L of D, the slenderness of the balcony. K, because it's a cantilever, is 0.4. FCK is 20. Rho 0 is 0.45%. And the rho is 0.3% because that's given. And then we got FCK is 20. Then again, rho over rho 0 over rho. And we arrive at the maximum slenderness of 10.45. This is very low because we have a cantilever. The span now is not known because the span equals to the 3,500 millimeters plus the condition on the support. And this is governed by the minimum of the thickness of the half of the thickness of the slab and half of the width of the support. The support is 500 millimeters width, but the slab we don't know. So this formula, when we use it, when we only use here the 250, means in fact that H must be bigger than 500. Otherwise, we have to adapt our span. So, but to go further with the calculations, we assume that H is bigger than 500. So from those two, we have L, the span, and we have the slenderness. We can find D, and D must be minimal 359 millimeters. The uncovered storage, it means that there is freeze and contact with rain. So it is XC4 or XF1 or EE3 for the National Application Document of Belgium. There is also slab geometry. So this means that we can lower the value of C. We can lower one class. So C is now 35 millimeters instead of 40. So with a concrete cover of 35, we have in the question, it was stated that the maximum diameter of the reinforcement is 16 millimeters, or tension reinforcement. So that's the point of gravity, one layer, first layer. And this is D, governed by the slenderness. So H is 402 millimeters. We, again, because now we know what H is, we again calculate the span. It's 3,500 plus a minimum of the two. And you see that now the minimum of the two is not 250, but 201. So the span now changed in 3,701 millimeters. So we recalculate the D, the effective depth, which is 354 millimeters. The depth, total depth of the slab is then the recalculated D plus the concrete cover plus the point of gravity of the tensile steel gives you 397 millimeters. Again, we check the effective span of the two. We have 3699. And when we calculate again the D that we need, we arrive at the same. So the iteration stops here. So B equals 354 millimeters. Now we will look at material resistance. For material resistance, the total load on the beam is 1.35 times the permanent load plus 1.5 times the mobile load. The mobile load is 7.5 because it's a storage place. So the total load is 24.65 kilonewton per square meter. The maximum bending moment is then the total load times the span squared divided by 2. It's 169 kilonewton meter per meter. And the optimum depth, needed depth of the slab is then 97 times the square root of the bending moment divided by the concrete quality. Bear in mind, the 97 takes care of units. That means the bending moment is in kilonewton meter per meter and the concrete quality in megapascal. And the result of this formula is millimeters. So then the optimum, the needed, the effective depth is 282 millimeters. We can calculate the needed total depth, which is 282 plus the concrete cover plus the reinforcement. It gives you 325 millimeters. But now you see that for material resistance, we need a total depth of the slab of 325 millimeters. But for slenderness, we need 397 millimeters. So you see that in this case of balcony, the slenderness is the most important one. So we round it off and the depth is equal to 400 millimeters.